Welcome to AP Podcast 15.7. This is on precipitation, and what this is basically the opposite of the last podcast. If you recall, we were trying to figure out what the equilibrium constant would be or what the solubility would be for a solution. Well, now what we're doing is we're looking at will a precipitate, or let's see, at what point will a precipitate be made. So in order to do that, we got to look at the ion product. Now, the ion product, you might recognize that letter Q. Remember when we were finding Q way back when in chapter 13 with equilibrium? It's still the same kind of concept, right? What we're going to do is we're going to find out by taking the concentration of the cation and the anion, we're going to find out what that value for Q would be, and if you can compare it to the KSP, you can see it right here. If it's greater than the KSP, then we'll get a precipitate. If it's less than the KSP, the concentration of the ions is not enough, and we'll get no precipitate. And then if it's a situation where those two numbers are equal, we will get an equilibrium. So let's try a problem, all right? Now I've got two solutions. I've got some cerium 3 nitrate and some potassium iodate. And as you guys know your solubility rules very well at this point, you know that cerium iodate would form a precipitate, all right? Or if it would form a precipitate in this case, you know, what concentration would it be? So here we go. We're going to find out if a precipitate would form. So we've got to do a little bit of stoichiometry because look at the values they give us. They give us 750 milliliters of that concentration of cerium nitrate. So just to kind of make sure we're on track here, let's just think of the net ionic, right? We've got some cerium 3 plus some iodate. Oh, and there's 3 of those, right? And we're going to make some cerium 3 iodate. Okay, so there's the net ionic. Now, in order for us to do this, we've got to think about, how many moles we have, right? So if I take 750 milliliters and times it by that molarity, 750, pardon me, how about this? 0.750 liters times 4.0 times 10 to the minus 3 molar, right? I get, let's see how many moles, pardon me for a second. Okay, you know what? I'm looking at my notes. I've got 750 milliliters per millimole per milliliter, right? And I'm sorry about that. We should keep it in milliliters, right? So this gives me 2.86 millimoles, right? But again, it's all about concentration. So what's my volume? 1,050 milliliters. And that's going to give me a value of 2.86 times 10 to the minus third molar of cerium, right? So that's this number right here. Let me change colors here. So I've got 2.86 times 10 to the minus third of that, right? And by the way, if you're wondering where I got the 1,050, look what we're adding. We're adding 350 milliliters to a solution of 300 milliliters. So it's a total volume. Remember when we were doing all our titrations, what a pain in the butt that total volume thing was? But we got to really focus on it. All right, so now let's find the concentration of I that we have. All right, so I've got 300 milliliters and times 0.02 moles, millimoles per 1 milliliter, right? And that's just this number right here. So I've taken those two, and that's going to give me 6 millimoles, right, divided by 1,050 milliliters, and that's going to give me a concentration of 5.71 times 10 to the minus third molar, right? So I've got 5.71 times 10 to the minus third molar right there. Now we're ready for the next step. So Q equals the concentration of cerium times the concentration of iodate cubed, right? And that's going to equal 2.86 times 10 to the minus third times 5.71 times 10 to the minus third cubed. And when we work that out, we get a value of 5.32 times 10 to the negative 10th. Okay, so that's the value of Q. Well, let's look at the value of the KSP. Look at that right there. Now compare those two. Okay, so since 5.3 to the negative 10th is bigger than 1.9 to the minus 10th, we will get a precipitate. Okay? And so there's how you do a problem. So let's look at my next example. Now what I think you should do really is pause this video and try this one all by yourself, and then see if you get the answer I get. Oh, scratch that. Don't pause this video. Now that I'm reading this question, I guess I should have been a little better. It's not the same kind of question. This is one of those classic AP Think questions. So let's look and see what would be the concentration of magnesium and fluoride at equilibrium. Well, let's do our Q thing and figure out if we are going to get a precipitate, right? So our basic precipitate reaction is magnesium 2 plus 2F minus is going to give us magnesium fluoride, right? Okay, so let's find out the concentrations of the magnesium. First of all, I've got 150 mils. I'm going to go kind of fast, guys. Times 1.0 times 10 to the minus second millimoles per milliliter. And then hopefully you can handle this. I'm going to divide that by the total volume. What's the total volume of the solution? It looks to me like it's going to be 400 mils, right? 150 and 250 divided by 400 milliliters is going to give me a concentration of 3.75 times 10 to the negative third molar. Okay, and then doing the same thing with the fluoride, I've got 250 mils times 1.0 times 10 to the minus first, 1.1, and then divide that all by 400 mils, and I get a concentration of 6.25 times 10 to the negative second molar. So Q is going to equal, we've got Mg 2 plus times F minus squared, right? Okay. And so now what I want to do is just plug those numbers in. 3.75 times 10 to the negative third molar times 6.25 times 10 to the negative second squared, right? And I get a Q value that equals 1.46 times 10 to the minus fifth. All right, let's see what we got up here. Look at the KSP, 6.4 times 10 to the minus 9. So obviously this is bigger, right? So we are going to make a precipitate. So now we can focus on the problem. Calculate the concentrations of magnesium and F at equilibrium with the salt. So we know there's a precipitate, and now we've got to figure out how much concentration of magnesium and fluoride. And this kind of presents an interesting little problem, because if you think about limiting reactant, I mean, look at the two concentrations here. Here's fluoride, right? And here's magnesium. And I think you can see right here that the magnesium is obviously going to run out first, and so fluoride's in excess. So let's figure out how much stuff we have. Let me go to a new slide here so I can kind of figure out what I've got. So fluoride, let's see, if I take 250 times 0.1, how many millimoles is that? Well, hopefully you're going, well, duh, it's 25, right? Oh, for crying out loud, now's not the time to have... Okay, so we've got 25 millimoles, right? And over here, we've got 1.5 millimoles. You guys with me here? I mean, look what we've got. We've got 150 times 0.01. And so they're going to react, right? And so we'll minus 1.5 and minus 1.5. And then you can see right here that we have 22. Oops. Boy, I hope you were screaming, yo, don't forget the coefficient, right? Not minus 1.5. How about minus 3.0? So we would have 22 millimoles there, right? So obviously we got a lot of fluorine sitting around. So how much fluorine is in excess? Well, let's divide by the total volume, right? We're going to divide by 400 milliliters. And look what I get. When I calculate out, I get 5.50 times 10 to the minus second molar. So that's how much fluorine is still floating around at equilibrium. But how could we find out that magnesium? Well, let's just set up a good old KSP problem, right? KSP equals Mg plus F minus squared, right? Now look what I know. I know this value, 6.4 times 10 to the minus ninth, right? I don't know this number, that's x, but I already know that this much excess is floating around. Would you guys agree with me? I hope you do. 5 times 10 to the minus second, square that thing, right? And now I can solve for x. And when I do, I get a value for x that equals 2.1 times 10 to the minus sixth, okay? 6. So that's the concentration of Mg2+. Now you can see these problems can get pretty convoluted and a little confusing, but we'll practice a bunch of these and hopefully get this down. So again, if there are any questions, I'll see you in class and see you next time.